Alrighty, what's going on, guys? Day 13. It is actually the next morning, not the night of it coming out. So the puzzle's been out for a while, but nonetheless, let's see how this goes. With your help, the hot spring team locates an appropriate spring, which launches you neatly, precisely onto the edge of Lava Island. There's one problem: you'll see any lava. You do see a lot of ash and igneous rock. There are even what looks like gray mountains scattered around. After a while, you make your way to nearby cluster mountains to only discover that the valley between them is completely full of large mirrors. Most of the mirrors seem to be aligned in a consistent way. Perhaps you should head in that direction. As you move through the valley of mirrors, you find several of them have fallen from a large metal frames, keeping them in place. The mirrors are extremely flat and shiny, and many of the fallen mirrors have lodged into the ash at strange angles. Because the terrain is all one color, it's hard to tell whether it's safe to walk or where you're about to run into a mirror. You do note the patterns of ash and rock as a puzzle input. Perhaps by carefully announcing the patterns, you can figure out where the mirrors are. Okay. To find the reflection in each pattern, you need to find the perfect reflections across either a horizontal line between two rows, across vertical lines between two columns. In the first pattern, the reflection is across a vertical line between two columns, arrows. Between two columns. Gotcha. The line of reflection is the vertical line between columns 5 and 6. Okay, so we just need to find... Okay. So just need to find the row 1 reflect with a hypothetical row. Row 1 reflect a hypothetical row 8, but since that's not in the pattern, row 1 doesn't need to match anything. Summarize your pattern. Add up the number of columns to the left of each vertical line. At 100 multiplied by the number of rows above. So we just need to find a reflection point. So like this one would be around here. Okay, so okay. This should be pretty. This should be a straightforward brute force. All right, so for this one, input as always split. Instead of on new line though, we're gonna actually be splitting on new line. That way we can get each individual like grid and row, and then we can split each grid on new line. Whoops. And we can split this every line on every character. So okay, and then once we've now done that, now we need to call our reduce again. To get our, is it just a sum? Yeah, it's a sum. Okay. And start at 0. All right. So now for the actual part of a grid, we need to find the reflection point, like the, I forget the actual, there's a technical term, I forget what it's called. Okay. So I think we can just brute force this. We can make a const is does reflect column. And so we'll give it the left, the right, and also the grid. String. And what we'll do for this is we simply just do we do a while. We do while left is greater than or equal to 0, and right is greater than or is less than grid 0 dot length. What we'll do is this will return true, and then we'll do a check here is if actually I'll just do so column's a little harder because column we have to go we have to go through all the rows, so we have to kind of do this a bit differently with grid. Let's do grid filter, and we'll do a line and an eye, and we can just do line eye array, line eye left. Actually, don't need array. My bad. Does not equal line I right. And so we just do a check here. If this filter length is greater than 0, return false, and that is it. That is actually it for that. Okay, so there is our column logic. The row logic is going to be very similar, but instead of left, it's going to be above, below. While above is greater than or equal to 0, below is that. Same thing on the filter, but this is a little bit easier in that we do above. Ooh, 0. No, we need to do, ooh, actually, is this one harder? Because we have to, oh wait, actually I didn't also, left. Sorry, right plus plus, left minus minus. Below plus plus. So I guess I can do grid above, and this I do need the array because I need to do array below. And this is gonna need I, and that's gonna need I. There we go. Okay. Right, I meant row. Okay, so what we'll do now is y equals 0. I guess we just go through. Y is less than, actually we can just do grid row we can just do this, right? And let's reflect row, pass in the grid again, and we can do above being row +1 and row. If row +1 is less than grid.length, I guess. I guess we can just do this, right? Otherwise, false. And I'm guessing they're only gonna have one, so I can kind of just do both. Actually, we can do a check here. If row reflect. Oh, but I need. No, this is. Let me turn the number. It said find index is what I want. Yeah, okay, that's what I want. Row reflect, and then we're gonna return. The row is 100 times row reflect, plus sum. Otherwise, find index, return sum plus column reflect. Okay, and then this one is different because now this is column. I'll do 0. Column +1 less than grid 0 length, and then does column reflect grid. We want to give it the left, which is going to be column, and then column +1 is the right. I did this backwards too, by the way. And now I can just do a console log part 1. Alright, brute force. Work, please. Reading 0, grid above. Line above. Oh, because it's getting a line. That should be... No, this should just be line as a whole. That's why. That's failing. This needs to be not array, this needs to be grid I. Okay. Okay. That's why that's failing. Alright, I was just, I guess, just didn't understand why this, or how this is working for whatever reason. This is gonna be the same way. This is actually the character. But I'm doing it on the grid. So it means that is the line. I don't need that. And I don't need that. Yes, okay. Yeah, this is the line. And I just need the characters to the left and the right on this line. There we go. Why was that such a struggle? Alright, not right. Okay. Let's plug the test in. Whoops. So that's there. And test. What do we get for our test? 200. Okay. Console log. Row. Whoops. Row. I can give it row reflect. And column. Row -1, row and 3. Oh. $304. I'm off by 1. It's because it's the index, which means I need to do +1. Alright. There we go. Now we're back in business. Alright, so this should be the actual answer for my problem. There we go. Alright. Made that a little harder than it needed to be. I resume walking through the Valley of Mirrors and smack run directly into one. Hopefully nobody's watching because it must have been pretty embarrassing. Upon closer inspection, you discover that every mirror is exactly one smudge, exactly one in the opposite type in each pattern. You need to locate and fix the smudge that caused the different reflecting line to be valid. What the heck? The first pattern smudge is in the top left corner. It would have to have a different horizontal line of reflection. Actually, this might not be too hard. Summarize your notes as before, but instead use different reflection lines. Sorry. Okay. Actually, this might not be hard because we don't need to go through and try to fix every character. What we can do is we can find reflections that only have one character incorrect. Okay, so I'm gonna do const grid just so I don't have to do this again. Okay, so part 2. Same thing, but change this to instead we need to get the number let wrong equals 0, wrong plus equals that. So I can actually do is array from I could do that. I'm not gonna do it right now. There's wrong, and we're gonna return wrong. So what's gonna happen now is that these are instead going to be returning how many are wrong, like how many ones don't match up, and we should only see one for the ones that are the change that needs to be made. And so what these mean now is, so this is going to be equal to 0. The first part is just going to be 0, because that way nothing changes. So we should still see good. But this is actually going to be just 1. And I don't think that's right. No, it is right. Wow. Ha. Alrighty. I went through, cleaned up the code to be, again, functional based, and then just be cleaner overall. So for today's problem, we're given this, we're given a bunch of grids, you can see here. And the goal of this is for each grid to find the mirror point or reflection points of this grid, either the row or columns between them, and then you then calculate the number of rows above or the number of columns to the left of the reflection line, I guess. Both these parts are done in the exact same way, so I'm going to cover them. Just the only difference is that part 1 looks for where they are a perfect reflection, and part 2 looks for where they are almost a perfect reflection. The only difference is that there's only one mistake on part 2. So for both of these, we first split up our inputs, find the grids, so split by new line, and then split into each individual grid. That way we have a 3D map of strings, and then we go through and we reduce. This reduce here is just for the sum, which is again 100 times the row, or just the column summed up. So to find the rows, we find the index of the grid where this does reflect row is 0 for part 1, 1 for part 2. The reason being is that for part 1, we are going through, and as we are going through and calculating if the line's a reflection, instead of calculating if it's a perfect reflection, we just simply return the number of characters that are wrong. So as we go through and filter our grid, so this is again for a row, you need the above and below indexes, or the lines, I guess, rows you're going through. So you grab the row in the grid for the above one, you've grabbed the row in the grid for the below one, and in this case we're just filtering. So we're going through every character in that row, and we're saying, does that character not equal the corresponding character in the below line? If it doesn't, it gets added to the filter, so it gets returned back by this filter, and then we simply get the length of that and add it to our running total of how many characters are wrong. So this is the same thing, columns the exact same way, it's just instead of it being the rows, it does the columns. And what happens is that this number of wrong gets returned by these doReflect row or column methods. And for part 1, we just check if it's equal to 0, because if it's equal to 0, that means that all the characters are perfectly aligned and in the correct spots, and that means we have the perfect reflection on this row or on this column if this one's true. Then we do the logic return it. Part 2, though, we look for the ones that are 1, that have one wrong row or one wrong row or column character. Because then that means that's the character that needs to get flipped, or that line or column has a character that needs to be flipped. We don't care which one it is, we just would know where it is. And that tells us the row and column, so we just know it's that row or column, and that's how we know which is the one that is just imperfect. And that is it. Pretty straightforward if you know this trick of just looking for the count instead of finding the perfect. So anyways, that'll about do it for day 13. Hope you guys enjoyed. I'll see you guys all tonight for day 14. Peace out.